Okay, perfect. Thanks, Harni. Ladies and gentlemen, a very good afternoon and welcome to this week's SPE KL Technical Talk series in support of members in transition. This is going to be our last talk of the series that we've been organizing for the past 10 weeks or so. It was a pleasure having seasoned professionals from the industry speak with us from fundamental petroleum engineering topics up to the latest talk of the town, digitalization, machine learning, and AI. So today what we're going to be doing is we'll be diving down back to our roots to discuss about deepwater exploration and drilling activities, whereby Ms. Harni Farihah from Petronas Charigali will be talking to us about well planning consideration in a deepwater development. It's exciting to see the numbers that we have dialed in here today, and I can still see some dialing in. We hope you enjoyed this session. We have close to 90, and if I remember correctly, when we first started off the talk, we had close to 100. It's nice to see that we have managed to maintain the attention span throughout our 10 technical talks. Okay, before I move on, I'd like to ask you to follow us on our social media account to keep yourself updated. LinkedIn would be the place for you to go for updates of our upcoming technical talks. Even though our MIT Technical Talk series is ending, but the SPE KL section is working very hard on delivering other quality programs. Most recently, if you've noticed from our LinkedIn page, we have launched Saturday for SPV, where we have curated workshop and technical talks for you. So please do follow us to keep yourself updated of our upcoming activities. For some of you, this might be your first technical talk that you're tuning in with us. Don't worry if you've missed the 9 technical talks. We have all up on our YouTube channel. So please head down to our channel by scanning the QR code on the screen. Other than the MIT technical talks up there, you can also find recordings of all our SPE events, including the recent Saturday for SPE talk, where we had a presentation from the head of SPE, Mr. Thomas, and as well as the head of Petronas Integrated Value and Assurance, talking about remote operations. So don't worry if you're facing any difficulties in scanning the QR code. I'm going to be sharing the URLs in the chat space in a bit. And your feedback is very valuable to us, and this will actually help us improve our upcoming technical talks and even organizing a second technical talk series. I kindly request you to take a couple of minutes to share your thoughts with us on this session and any other thoughts or topics that you might be interested in. I'll also share the link for the feedback form in the chat space if you're facing any difficulties with the QR code. Before we start, I'll be laying some ground rules to ensure we run the session as smooth as possible. The lecture will last for about 50 minutes, followed by a 20 minutes question and answer session. Once we've cleared all your doubts, we'll be jumping into an interactive Kahoot session. So this quiz is not only aimed at gauging your knowledge of the understanding of the topic, but there's also a golden opportunity for you to grab a 50 ringgit e-wallet voucher sponsored by SPE Kuala Lumpur. So stay attentive throughout the session and you might be the lucky one to win. We also suggest you to mute your microphone if you're not speaking throughout the session to ensure there's no interruptions. And we'd like to remind you that this session is recorded. So if you have any questions throughout the presentation, what I'll suggest you to do is to drop them in the chat space. What I'm going to do is at the end of the session, I'm going to grab some questions and I'll ask Harni. And if you feel like talking to Harni directly, once we have ended the session, in the Q&A session, you can unmute yourself and ask Harni yourself your questions. And to the lucky winner of the SPE Kahoot quiz, I'll suggest you to stay online with us after the session so that we can get up your details to send you the 50 ringgit e-wallet voucher. So now I'll like to pass the floor to our program director, Rosmawati, to speak to you about our SPE membership and also give you a summary of all the events and talks that we have conducted over the 10 weeks.
Hi, thank you Avinash for the great opening. Assalamualaikum, good afternoon. My name is Rosmawati. I am a program chairperson for SPE Kuala Lumpur. We decided to skip the membership talk today and just summarize about what happened for the past, for the past 10 sessions. Before that, of course, there's no membership talk, but a friend of mine just told me that he's not a big fan of SPE because SPE is expensive. I admit that. I paid $80 before. Just to highlight that as a professional, you can keep on your membership for $20 a year. Of course, we didn't see any of this dollar coming into SPE KL. We get only a fraction of this, but do support us and join to keep all of our program continue. Okay, next, Avinash. SPE Kuala Lumpur MIT, member in Transition Talks, Technical Talk Series, is also a program that has been done all over the world. Some people ask me what is transition. In transition means it's nothing to do with gender transition. What it means is there are some of us who are actually unemployed or in between employment, or students who are graduating or have graduated and have not secured a permanent job. Therefore, in transition means it's a nice way to say you are in between job, and that's okay because the learning should continue. So in support of this, we'll have speakers from the industry to help in terms of keeping you on track with what's going on and anything new in the industry. So with that, I would like to give my thanks to all the speakers that we had for the past 10 weeks. Next slide, Avinash. So for the first week, we have Mr. Nikhil Hadikar. Second week, we have Ms. Fatimah Mehran, who is also a member of SPE KL committee. Next. Third week, we have Mr. Babak Moradi from 360 Energy. And from the fourth week, we have Rafiq Laza, who is a job model international. He connected to us all the way from Dubai. And then we have Mr. Izwan Shahmin from NPM, Mr. Sujit Kumar from Sat Energy, and he was virtually connected to us via from Mumbai in India. Next, we have Mr. Balaji Channakrishnan. Some of you may know him. He's from Terresto Energy. He worked with Petronas before, and who forget Miss Amy Yusnita Yusof and her energy during the presentation. Next. Last week, we have Mr. Ahmad Adib bin Abdullah. And last but not least, we have a cute lady, Miss Harni Farihah, for today. Okay, and finally, last but not least, I'd just like to highlight my team who has, for the past 10 weeks, has worked together with me between their free times at night or in the morning to make sure that this program go on as planned. From the top left, Mr. Faiz Latif, founder and CEO of Semarak Training. Faiz is here. And next to me is Mr. Faizal Nazir from COE. In the middle row, Mr. Avinash, which is your moderator for today. He is an engineer with East 101. And then in the middle too is Mr. Haziq Yazid and Ms. Aina Jaiz, both are working with ExxonMobil. And on the right side is Ms. Isha Azman, currently working as a procurement analyst with BHP Billiton. On the bottom row, we have Ms. Raji from SMSN Management Services. I think she might be currently offshore. And then we have Ms. Havin Kaur, a lecturer from APU, and last but not least, also Ms. Ismatul Hani from Petronas. Therefore, that's it. That's our team. Thank you very much for my team. On behalf of my team, also, I would like to apologize if there's any shortcoming. If there's any feedback, please get back to us on our social media, whether you want to have more of this coming or you are kind of like sick of it. But that's okay. Do give us constructive feedback. I will appreciate that. Thank you very much. And over to you, back to Avinash. Thank you, Avinash.
Thank you, Rose. Thank you for summarizing and giving the community an idea of what Members in Transition is. I think a lot of people have asked me as well. And I would like to personally take this opportunity to thank all the speakers for spending their time and effort and sharing their knowledge with us, and also the team that has worked alongside me all these 10 weeks. Thank you, guys. Thank you, everyone. Okay, without further ado, now let's move on to the topic for today, Deepwater Development Well Planning Consideration. I think over the recent years, we've seen a major shift from shallow water exploration to deep water exploration. This is evident all around the globe, especially in the pre-salt region of the Brazilian waters, whereby we are seeing large developments with close to 7 FPSOs. Even in Malaysia, we're witnessing a transition to deep water development field with the Limbayong field that's coming up really soon. So this is primarily due to the depleting shallow water reserves, and deep water is seen as an area to revive the oil and gas industry. The exploration and development process is inherited to many unknowns and challenges, as we all know, which is further amplified in this type of deep water development. And if these challenges are not addressed and tackled adequately, they may pose a risk that result in the project of being unattractive and irrelevant. Hence, in today's talk, Ms. Harni will be sharing with her experience of the challenges that she has faced in deep water development and how she maneuvered her way through it. She'll be supplementing her experience with lesson learned, best practices, and recommendations for future FDP planning with all of you here today. So I'd like to take this opportunity to give a little bit of background of Ms. Harni Farihah, our speaker today. Ms. Harni is currently the manager for wells at Front-End Engineering Group of Petronas Carigali Sembilan Berhad. Her work is focused on exploration, appraisal, field development plan, as well as block acquisition. She has been in the industry for close to 15 years with experience in both domestic and international oil and gas industry. She's an expert in deepwater drilling with both experience and exposure to managerial roles as well as operational roles. Apart from a management and operational, sorry about that. Apart from a management and operational roles, she also holds a developer role in Wells Deepwater institutional capability within Petronas. This is an internal arm in Petronas that plans knowledge transfer and knowledge retainment programs for staffs within the Wells department of Petronas. So apart from a day-to-day job in Africa, she also actively gives back to the society through her involvement and sharing in deepwater conferences. Without further ado, I'd like to invite Ms. Harni to deliver her session today. Thank you. Harni, over to you. I've stopped sharing the screen.
Okay, thank you, Avinash. So let me share my slide.
Sure. Okay, perfect. I can see it.
Sorry, is it in
It's in the presentation mode, and I can see a lot of thumbs up. So I think everything is okay for you to start.
Okay, because I have two screens, so I'm not sure which one is showing which one. Great. Okay, so good afternoon, everyone. I hope all of you are in a ping of health. Thank you for joining this session today. So as you have heard previously, this is the last session organized by SPE KL. So let's also take this opportunity to congratulate them for able to organize the first series of technical talk. Yeah, and I was told this is the only session conducted for by driller. Yeah, probably drillers are shy, maybe. So thank you to the organizer for reaching out to me and giving me the opportunity to share my experience today. Okay, I'm Harni from Petronas Carigali, currently the manager for Wells Front End. And today I will share with you the Deepwater Development Well Planning Consideration. And this is purely based on my own experience when I have to deal with several deepwater field planning exercise. This is not specific. Whatever that I'm going to show to you is not specific to only one particular field, but this ranges from FDP program to ADP program and even those high-level feasibility study. Okay. All right. So this is my presentation outline. Now let me change it to. So I'll cover a little bit, just a high level on the project life cycle and give some overview of the available deepwater development concept that we have in the industry. And before I zoom into a bit more detail on the steps or iteration process that we have to go through in order to come up with the well design. Okay, and then here comes the exciting part is for us to understand more the seabed hazards and the layout limitation as well as the subsurface hazard. So once I've explained all the types of hazards that I've experienced dealing with, then I'll share with you what are the impact that these hazards have on our well planning. And last, I will touch a little bit on the APB management. So I was given around 40 minutes, so I hope I can finish it in 40 minutes time. Okay, so just a bit, this is, I think most of you are already aware of this project life cycle in any particular field. So this is pretty much standard. So the typical project starts with the exploration well, whereby we find the oil or gas, we search for the hydrocarbon. So upon discovery, then we will embark on the appraisal well. And this is I would like to highlight the difference between exploration to the appraisal scope from shallow water to deep water, whereby in exploration, shallow water exploration well, when you drill and you found a hydrocarbon, you have the luxury to conduct DST right away through the call-out basis, right? But this is not the case for deep water. And it is for two reasons, and that is the reason, and because of these two reasons, a deep water well will not have a DST plan during the exploration stage. Okay, so what are the reasons? The first one is the equipment is rather expensive for you to book or to mock, and there are not that many DST subsea tree available in the market, so you have to book it upfront, and that's expensive. Okay, and in the event that sorry, in the event that there's no discovery, so there's already a sunk cost to you. And second is because of the water column, right? You have to run this inner string for the testing, and this inner string will be inside your riser and BOP, and each water depth is different for each well. And when you want to do that appraisal, you have to align, or you have to run your tally in such a way that your BOP, so your inner string, the connection of your inner string is not going to interfere with your BOP operation. So before you can embark on an appraisal stage or appraisal program, you have to run a tally, and if it's not readily available, you have to manufacture this called a pub to space out your inner string so that you don't interfere with your BOP operation. So those are the two things and two distinctive things, difference between exploration and appraisal for shallow water against the deep water. So that's why you can see we don't recommend doing a well test in exploration stage. Okay, now you already have all the data, and it is very important for you to have as much data as possible during the appraisal stage, because that will help you to plan a proper development plan. So you need at least the core data and the DST data for your completion later on. And typically, the duration between the exploration to the first oil or first gas takes around 5 to 7 years. This is backed up by the IPA. This is backed up by the IPA. So typically worldwide, it takes around 5 to 7 years. But in certain cases where you have a nearby facilities that you can tie into, then the duration can be shortened. Okay, so remember this keyword, 5 to 7 years. All right, so now that you already have all your FDP in place, you're ready for your development. You've produced throughout the entire field life, and you're ready for your decom process. All right. Next is okay. This is just a little bit of overview. Okay. This is not my forte actually. This is from the facilities of subsea, but for wells, or even for subsurface, you need to know this, because we are going to work hand in hand together, and you need to know at least high level information of what are the available concepts that we have in the market for the development, for deepwater development. So in order for you to select this one particular concept, you have to understand what are the factors. So for example, the number one factor is your water depth. Okay, so each concept, for example, here, the compliant tower, you can, it is suitable for a water depth of around 1,000 to 2,000 feet. Okay, and as your water depth increases, then you have to look for the different kind of concept. Okay, and it depends. And second factor is on your field shape. So for example, your field shape is elongated. So elongated meaning to say you probably need two drilling center, two cluster. So the best bet for you to develop this field is through this FPSO. So FPSO will be in the middle, and then you have all these riser and flow line connecting all of them. So and economics also plays an important role, whereby if your field is it's of a marginal field, so FPSO is also the best option, because typically FPSO is like an old oil tanker that you convert it to become the FPSO lah. Okay, so all of these are deliberated thoroughly during your concept ID or concept select. Okay, and there are three types. I mean, there are actually only two types of tree, which is dry tree or wet tree. But there's a mix of a hybrid that we call, you can start drilling using a wet tree. For example, you do your surface hole section using a wet tree. Sorry, not wet tree. You use subsea wellhead. Okay, and then when your mopu is ready, and then you continue drilling from the platform itself. Okay, so that is what we call hybrid, and it's typically for it is suitable for fixed platform, TLP or SPA. Okay. All right. Okay, this is the part that I'm going to spend a bit more time. This is the iteration. Okay, the well design and trajectories have to undergo numerous iterations depending on your data maturity. Okay, for any FDP, once you embark on FDP, the field development plan, you have to go through all these gates. So it's called this front end loading, FEL 1, FEL 2, and FEL 3, whereby the FEL 1 is the initiation of the project, FEL 2 is the scope selection, and FEL 3 is the scope definition. So in Petronas, we have this called CWP, Collaborative Well Planning. It's a forum for us to discuss and collaborate together with various parties. And here, if you can see, there's a triangle here which connects all the three main parties. I'm not saying the rest are not important, but these are the main that will have to go through the process together until the end of the cycle. So we have wells, we have subsurface, and we have facilities. Okay, so I will share with you and also share what's the difference when we come out with the well design for deep water versus the shallow water. So the first one is for us to get the target, of course, for us to get the target from the subsurface. So once we have identified the target location and we know where is the surface location, then we come up with our trajectory design. So that is pretty much straightforward, and it's the same for shallow water or deep water. The difference is that the facilities part is different, whereby for shallow water you have your platform and your surface is fixed to that platform. Okay, but for deep water or subsea, this is where your facilities friend come into picture. So once we have the trajectory, and we have to select whether our surface location is actually suitable for us to place our wellhead. Okay, So that is the first collaborative first CWP session. Then as you move on through your process, you will tend to get more information coming in. For example, you will have during the scope select, you will conduct the site survey. Okay, you have to conduct your site survey lah. First, you have to use your desktop site survey using your 3D seismic, and then you have your initial for pressure fracture gradient prediction. So that's one iteration. Then, for example, you will have your actual site survey conducted, physical site survey conducted, and you will tend to get more information to validate your seabed condition. So this is the part where you will check whether the well that you originally placed, the location that you chose, is free from hazards or otherwise. For example, this one you have one very hazardous character there. So you have to check whether this is of the safe distance or otherwise. Okay. So when you have that site survey information coming, you will have to validate, and then if there is a need for you to change, for you to relocate your well placement, then you have to go through the trajectory design again, and you have to inform your facilities, because the facilities also will do their part on the surf layout, on their facilities layout. So once you move your well location, everything else have to move together. So there are three parties that you have to consult. I mean, wells, subsurface, and facilities. Likewise, if subsurface tend to have a new update, say for example, they do a seismic reprocessing, and they found out that there's a better sweet spot, and that's where we want to target to achieve. So you have to change your target. So you have to check again. Once you change the target, is it still reachable from the originally planned location? If not, then you have to change. And when you want to change your your surface location, you have to go through that process. So it's very iterative, and I don't know, maybe we've gone through more than 10 times of a CWP session. So it's a continuous effort. Okay, now that let's say your seabed your seabed is fixed, the target is fixed, and then you have your updated for pressure and fracture gradient, and suddenly you have a new data coming in from the additional appraisal well, or you have from the additional pressure appraisal well, you have a data from core for example, and your geomechanics is screwed up. You can't reach that target without additional testing because you are running out of margin. First, you have to remember, in Deepwater, you already start with a very low margin, or a very narrow margin. Margin meaning to say that your window, your gap between your pore pressure and fracture gradient is small. Why? Because in Deepwater, your water column will take over and replace and reduces your overburden pressure, and that will have an impact to your fracture gradient. So imagine your pore pressure stays the same, but your fracture gradient is getting smaller and smaller. I mean, lower and lower. So leaving only smaller gap for you to design your well. So sufficient margin is an issue as well. And the deeper you go, the deeper your water depth, the worse it gets, depending on the location as well. Okay. And last but not least is depending on your what's your completion strategy. Okay, so if you need a frac pipe, so you know that you're pretty much limited to the angle for if you want to complete in a frac pipe, and if you want to go to maximize your PI, then you'll go with horizontal. But what happens if you don't have enough margin? So how do you plan for that? So those are the things that you need to take into consideration, that you need to actually know and validate whether those are actually going to pose you going to affect your well design. Okay, so now let's take a closer look at the seabed hazard. Okay, so seabed hazards and surf layout limitation. Actually, when we talk about shallow water versus subsea, yes, subsea people tend to think that it provides flexibility in well placement, yeah, but it's not always the case, especially when you have complex seabed features and also the surf layout that will have limit that will somehow limit your options. Okay, so these are some of the hazards that I've actually encountered during my work lah. So let's go through. This is actually not from the any of the field that I've worked. Okay, everything has been replaced with Google for the confidentiality purposes, but it's somehow similar. I mean, I just want you to understand what are the hazards that I've encountered and what are the hazards that you have to look for when you want to drill, or sorry, when you want to design the well. So let's take a look here. So one hazard that we have encountered is actually telecommunication cable. So yeah, the internet cable. So can you imagine if we do not do a proper actual site survey, AUV survey, and we simply drill and place our well there, and the whole Malaysia goes out of internet because of my fault. So we don't want that. So first, you need to know that you have to run the survey to validate. Sometimes the as-built is not the same as the final one. Okay, so when we validated, we can actually saw that it's a very long, extensive cable that connects it connects two countries. Yeah, it's a communication cable. So what are the options that we have at that time? We have two options. One is to relocate the cable itself, but it was actually expensive. It is expensive. Okay, to relocate the cable is expensive. And second is we have no choice. We have to relocate the well. So again, when you relocate the well, you have to go back to the CWP session. Remember, the moment you change your one element, you have to go back to the CWP. So that's one thing, cable. Pockmark and channels. This is pretty much, I think you have heard this many times already. Probably this is not something new. So pockmarks and channels. Also something that you have to validate from your survey, and you want to stay away from those locations. Steep slope. Okay, in one of the particular area that our project was looking into has actually a very steep that ranges, I think, more than 30 degree, more than a 30 degree angle. So we can't put our wellhead there. As a matter of fact, we can't put our subsea equipment also there. So our standard actually limits the slope up to 5 degrees only. Okay. So we have to look at the safe area where we have a rather forgiving slope lah. Okay. And the recent one, this is very interesting, is on the mud volcano. Something that we found out in one of the projects. So if you've heard about this Lucy field in Indonesia, so the mud volcano, it's like, you know, you have a volcano on the seabed. So this mud volcano is actually you have to check whether it's still active or not. But in the case of Lucy, it is still active. It's spewing mud and brine, and it caused a huge cratering, you know, like a sunk hole of up to 2 kilometers away. So yeah, 2 kilometers. And so for us, we have to, I think we had more than 7-8 sessions to properly understand and to probably come up with one number to say that, okay, 2 kilometers is actually sufficient for us to put our well location. So it is a safe distance for us. This may vary to other operators lah. Okay. So these are among the hazards that is present on the seabed that you have to investigate. Okay. And the next one is actually not a hazard lah. This is actually a surf layout. So surf is actually the subsea equipment, subsea umbilical riser and flow line. Okay, so once subsea, the facilities team have matured their design similar to us, they also have to mature the design, they mature the layout. So this clear seabed will be like a floor full with Legos. So now you know where is your exclusion zone that you don't want to step on, or where is your free zone. So we think like subsea, it gives you flexibility. It does, but not always the case, especially in development. So for example here, okay, this is something that I took and I simply draw. This is definitely not to scale. So exclusion zone is a place where you can't do anything because facilities have already fixed all these lines. They have the flow lines, the jumper, you know, all the fancy things, the manifold, the power thing, a lot of things on the seabed. So you can't simply put your well there. But in the case that you have to respite for whatever reason, there will be an area, a safe area for you to respite. So before you can respite, you need to consult your facilities team first. Where is our safe zone? Okay, and this thing will come out only at the later stage when the surf contract has been finalized lah. So when they come up with this, again, we have to go back to the CWP if we need to change our respite location. All right. Okay, now we're done with the seabed hazard. So we are pretty much fixed. Okay, we have a safe corridor where you can play around, where you can relocate your wellhead. Now we have to go through another process of hazard identification for the subsurface portion. So when we talk about subsurface hazards, we are concerned on the big three: the high risk shallow gas, shallow water flow, and in situ hydrates. The most challenging hazard to mitigate is actually the high risk shallow gas, especially when it is expensive in the field. So this is not really something that we have seen. The more expensive one, the actual one, but I can't put it. I can't share it here. So this is like the most. We imagine this is very expensive already. So actually, it does not pose a significant hazard to the drilling rig as compared to the shallow water operation. Okay, why? Because the gas somehow will travel it will travel away actually from the rig. Remember, you have a very large water column. So gas, when it travels, it will be swept away by the underwater current. So it will not affect your rig stability, unlike the shallow gas hazards in shallow water operation. Okay, but it will jeopardize our well, where this gas may turn into hydrate plugs. Okay, so when it travels on the seabed temperature is very cold, typically around 4 degrees C. So it will tend to crystallize. Okay, and it will plug our borehole and eventually it will junk our well. So this is one of the issue with shallow gas. It's not because of the impact that it has to the rig, but it's rather on the hydrate issue. For shallow water flow, it is actually our bread and butter. Okay, shallow water flow is manageable, to be honest, with DKD. The DKD is dynamic keel drilling. What is shallow water flow? It is actually there's a pocket that contains pressurized water in this pocket. So when we drill, it will be released. So this is an actual picture of shallow water flow that we caught on ROV. Okay, so what do we need to do is actually prepare a sufficient amount of DKD. And how do you determine that amount of DKD is depending on the suspected depth of shallow water flow to occur. And then you have to calculate the volume for you to switch the DKD. So DKD is dynamic keel density, which is technically it's just a keel mic, like a pad mic. So you pump around 11 to 13 ppg to drill through this interval with a pad mic. Okay. So this is also important for development later on, that during the exploration and appraisal, it's best for you to investigate the depth of this shallow water flow. First, you need to investigate whether that field actually has shallow water flow or not. Sometimes the prediction can be 50-50 and it does not occur. But if it occurs, then you can say pretty much the whole field will actually have shallow water flow. But you need to investigate the depth. So rather than you prepare a DKD mud and straight away use the DKD mud from when you come out from the conductor shoe, it's best for you to just drill with seawater, but with the control speed, and then you switch to DKD once you see the flow coming. So you know at least the depth, and you won't waste so much money preparing the DKD mud. It's expensive, yeah. Or you can switch to RMR. It's a technology called reservoir mud recovery. So it's basically creating a closed loop system. You have this pump placed on the seabed, and you have a return conduit. But this RMR is quite limited to the water depth because I think as of now, the technology allows up until 1,000 to 1,000 plus, just above 1,000 meter water depth. And beyond that, you probably need to use sacrificial casing or tubing as your return conduit. Okay. And the third hazard is the in situ hydrate. So this is basically an undisturbed crystallized water and methane mixture that is already a part of your formation, typically near your seabed. And this is all usually occurs during your riserless section, which is during your surface casing hole section. Okay, so mitigation. Sorry. When you drill and when you disturb, typically during production, you will expose this you will have hot fluid, and then the heat will dissipate, and it will disturb the hydrate condition to a point that it will dissociate and it will free the methane gas. Okay, so if you and then you will leave a cavity that can cause crater and jeopardize your well integrity. In terms of mitigation during planning, of course, if possible, we want to relocate, but sometimes we can't. In one of the case here, we couldn't. So what we need to do is actually incorporate slag cement, which is a cement with low heat of hydration for our surface casing cement slurry. And then you also need to do a specific study. This is called hydrate dissociation study. Okay, so this study will determine whether during this production, during this much amount of temperature and heat, is the hydrate going to be dissociated? And if it does, it will assess the effect that it causes to your well architecture. If the dissociation is severe, there will be a need for you to install certain mitigation such as VIP, like vacuum insulated tubing, or a hydrate deflector. Okay. All right. So now you know what are the risks that we typically see for both seabed and subsurface. So this impact typically it will somehow impact our well design in the development stage. Like I said, typically people thought that subsea is easier to plan because you can just place your well anywhere. Yes, it is true for exploration and appraisal, but not in this case of development well. Okay, so this is actually an actual well architecture in one of the field. During the appraisal, we only had about 4 hole sections. Okay, but when we mature the field, the FDP, to come up with the development well planning, we actually had to increase to 6 hole sections because of the hazards that I've mentioned earlier on. Okay, So one of it is the remember the high shallow gas anomaly. Okay, so in certain situation, we have to satisfy our requirement uh, to have that surface casing to be set before we hit the next anomaly, so that we can enable drilling of the next hole section with BOP installed. So because of that, we have to shift our 20-inch casing about 150 meters shallower. And because when that will create a domino effect. And to make it even worse, this field is actually a very narrow, it has a very narrow margin. So uh, we already have to shift to set our surface casing string shallower. And we have to add additional liners so that we can reach our target. So if you wonder why development, the water costs you so much, very high capex, so this is one of the reasons. Okay. All right. So these are the limitations. These are the impact. Okay. For the seabed hazards, you have limited well placement. You can end up with a longer trajectory. Imagine, you can actually place your wellhead here and hit your target here, but because of your hazards, you have to move it away, and you will tend to drill a very long hole section because you have to move from the seabed hazard. Okay, and then facilities layout optimization as well, and you have a limited relief well placement or reachability. For the subsurface hazard, the impact will be you will have to have a deviated well. You get additional casing. You have to increase your spec material, and so on and so forth. Okay. Another aspect that needs to be greatly considered in deepwater, subsea. This is not only for deepwater but also shallow water. But as long as you use a subsea, this is a problem. Which is annular pressure buildup. We call this APB. So annular pressure buildup will happen with two components. You have a trap annulus and you have heat from your production. So when you have a trap annular fluid heated up, okay. So imagine, let me show you this one. So in our schematic, we will call this annular A, annular B, and annular C. So can you imagine I'm an annular B, and and we are producing, and I have a fluid in me, and during production, the heat will cause me to expand. So I am the annular fluid in annular B. So I'm expanding, and I will push my wall on my right side, which is next to the annular C. So, and my wall on the left side is actually annular A. So when I push this, I will tend to burst my own casing, my own annular space. So I will burst my casing. But for annular A, I will push it until it collapses. So that's what APB does to your casing. Okay. But this is and this is different in shallow water, surface condition, where you can easily bleed off your annular pressure. In subsea, you can bleed off only from your annular A, okay, but not for B and C. So that would create this situation of having a casing collapse and burst at the same time if it's not properly mitigated. So these are several measures or mitigations available for APB, and you have to check whether which one is suitable and economical to your project. Okay, remember your deepwater is typically expensive, so you don't want to over design it with something that's you can be done cheaper. So the cheapest, not the cheapest lah. The easier one is on the left side. You change your material. You either change your steel grade, for example, X56 to X80, or you increase your wall thickness. Okay. Or you eliminate the trap annular pressure. You eliminate the annular, okay, by having that particular annulus fully cemented. But remember, you have a low frac gradient, and this is typically for deep water. You have a low frac gradient, and you want to cement you want to cement to surface. You're definitely gonna have frac or probably have losses lah. And you'll probably end up leaving some gap. So that's your trap annular. Okay. The cheapest one is actually open shoe. Well, you don't cement to your previous casing shoe, so you leave a gap for the pressure to escape. But this one you have to cross check with your company's requirement. Like for us, we need to satisfy 150 meter cement coverage on top of topmost hydrocarbon. And you also need to leave sufficient gap from your top of cement to your previous casing shoe. Why? Because if, over time, you have your barite stack. So you thought you leave an area for your pressure to escape, but you actually turned up to plug it. So you have to check these two conditions. Okay, and the rest are the equipment. So I think I'm running out of time. So the rest are some of the equipments available, tools available in the market. You really have to talk to the provider on how and where to install them. For example, the rupture disc, and you can for the relief, or you can balance your pressure by having your nitrogen spacer. But you have to calculate the right formula. There's a percentage, so for you to allow the nitrogen to shrink to give the space. Or you can isolate it from happening altogether by having the VIT. Like a thermos, you don't allow heat to travel or to dissipate. So you will remove one element from making APB to happen. Okay, so this typically is sometimes you need to select two methods, two mitigation methods, so that you have a redundancy. So it can be a combination of open shoe and rupture disc or nitrogen spacer. So it depends on what your analysis says. Okay. That is my last slide. So thank you for listening.
Thank you so much for the
Wow, 200.
Thank you so much for the wonderful presentation. I wanted to remind you about that. I think when we started off, we were about like 50 to 70, and now we have 3-folds of that. And I think personally, this is the highest number we have recorded on the Members in Transition talk. I think you have a huge fan base out there, Harni. And that was definitely an interesting topic. I really like the way that you approached it. From you categorize the hazards into subsea and surface hazards, and how that actually impacts the design and how you actually handle APB. It was a wonderful presentation. And if you notice on the screen, you can see so much of claps and love towards you. I think they really love the topic.
Thank you.
Okay, Harni, before we move on, I'm going to take a short break for you. What we're going to do in this break, I'll let you get some air, get some water. In the meantime, since we have 200 attendees here today, and this is our last technical talk, I want to make it memorable. If all the attendees can mute and, sorry, not mute, but share your video, I'd like to snap a picture or to make this a memorable one. So please, I'll give you around 3 minutes actually to turn on your cameras, then we'll snap a picture. Okay, thank you, gentlemen. Turning it on. Faiz, are you here? Are you still here? If you could help me snap, that would be great.
Yes, sure. Avinash, thank you. So just like Avinash mentioned, this is a record-breaking number of participants for our session. Thank you so much for your participation. And this is my first time as well to take picture of 200 people. Bear with me for a while. Okay.
Okay, let's give the guys another 2 minutes. They probably want to put some makeup on, adjust their hairs before they turn their camera on. So we'll snap the picture at one shot, and we'll do it in two modes. One, we're going to do the normal one, then the other one we'll do in the together mode, so we can have more people in the same screen.
Wow, such an audience. Record high.
Yes,
World
January.
record. Malaysia record.
Thank you so much. Okay.
That's a great turnout.
Oh, that's very good. Yeah, I think we can take using the together mode.
Okay.
Shall we take now or we wait for a while more?
Sure, let me go on together mode.
Yeah.
Yeah, okay. I still have some empty seats there to be filled. So let's give another minute or two.
Sure.
Hey guys, come on, be a part of this memorable journey with SPE MIT first technical talk series that we've organized.
Last one. Come on, guys.
And the last one.
For this year, last one for the year.
Yeah.
Or maybe the last one for the session of the year. So you're not
So
sure.
how many do we have right now on the together mode?
A lot.
At least half?
50, 60, I think.
It's only a quarter. I think we can wait a few more?
Sure. Yeah, let's wait for a while.
1 or 2 minutes more.
There's almost 60. I took the liberty to count. There's almost 60 of us here.
Almost 60, yeah.
Yeah. I still got some empty seats on the corners of the lab. Looks like lecture hall.
Let me see the together mode. Oh, wow. The theater has still got some space. Come on, guys.
Yeah.
Still got some space.
The corner seats, only the corner seats are left.
It looks like Chan Tat Leong to me, right at the corner, at the behind. Is that Chan?
It's good to see everyone's face. Beautiful, beautiful. Okay.
So maybe we can do like a lucky draw for today, because we have received the SPE pin. So maybe people who turn on the camera, maybe we can choose a few. What did you say, Anwar?
Yeah, let's do it.
I'll leave it to Avinash to select a few.
Okay.
Macam mana? How
to select? Give me some guidelines.
That's a good question. Okay, maybe
I see.
Quiz.
Yeah.
Why don't we do it this way? The quiz we give, we normally select the first one, right? Why don't we select the second and third one, Kak Rose?
Up to you. Recently, we're gonna get a special pin, a pin label pin from SPE KL, specially made. So it's gonna arrive soon. So 50 ringgit for the first prize, and there's a few more. I leave it up to you how many you want to choose. Okay.
How many?
I agree. Okay, maybe 4 or yeah, up to you.
Sure.
So are we taking picture now?
Yep. Let's take the picture and then let's move on to the question and answer session. Faiz, over to you.
Okay. I'm going to take at least 3 shot. Yeah. Let's do it. Number 1, smile. 1, 2, and 3. Wait a little bit more. Second shot with large gallery one. Wah, there's a lot of Malaysia flag now. 1, 2, 3, smile.
Faiz, boleh tak kita buat semua orang tunjuk dekat Puan Harni? I don't know how you all, since if you all can see together mode, you can show her actually. You can point towards her.
Yeah, okay. So
everyone point towards her. Just direction towards her enough. Yeah.
Where is she? Okay.
Okay. She's in the middle.
2, 3.
Okay.
All right.
Okay, perfect.
So much.
Okay. Good. Great one.
Let's share the picture in the chat.
Sure, I'll check.
For now, and then we'll put it in our social media. Thank you, Faiz.
Okay, thanks everyone.
Okay, now, Harni, let's go back to the question and answer session. At the moment, I don't see any coming in from the participants. Rose or anyone from the committee, are you seeing any? Okay, I just got my first question here. It's from Fahmi Mustafa from COE Upstream. His question, Harni, is that, is it still a standard to set conductor pipe at around 80 meters below mud line, BML?
It depends on your soil strength. I did not touch on that. So basically, there's another study you have to do, which is geotechnical study. So you need to acquire soil. Once you have firmed up your well location, then you need to acquire the soil sample. So that you can run a proper conductor analysis to determine what is the safe conductor length, conductor joints. If you don't have that, then you won't be able to know whether the 80 meter is actually sufficient when you leave your Christmas tree on that conductor, or the worst case is when you have your apa ni, well containment. So you have to know, you have to run that analysis. But it's around for Malaysia region, it's around there, 70 to 80 meters below mud line.
Got it. So it's going to be case by case basis, which shall be determined based on certain geotechnical studies, right?
Yes.
Perfect.
It's a very field specific data that you have to acquire.
I can imagine. Okay. Harni, a second question is from Irshad Fajar. I think he's from International Oil Upstream. He said, wonderful presentation. His question is that, can you please elaborate more regarding RMR? How does it really help in mitigating shallow water channels?
Okay. It won't help you to mitigate. I mean, it won't prevent you from entering the shallow water flow, but it will help you to save the amount of DKD mud that you have to use or you have to build. RMR is like you place a pump on your seabed and you connect it, so and it will create a closed loop system, and you will have like if you use a pet mud is a pump and dump. So same thing for DKD, you pump and dump. So you pump and you won't get return because it is during your riserless section. You don't have riser for you to have the fluid to be returned back to surface to be reused for the next well. So with this RMR, you have a return conduit and you have the subsea pump that will pump the fluid, the pet mud or the DKD mud, sorry, so that you can create a closed loop system, and it's like having a typical riser, but it's not a riser lah. So you can preserve that mud to be used in the next on the next well, where you have to mitigate that shallow water flow. So it's a matter of saving your mud and for your logistics, ease of logistics as well.
Okay, perfect. I think it makes a lot of sense to actually save the expensive mud rather than being lost and reusing it. Okay, the next question that I have here is from Faiz Latif. He said, wonderful and insightful presentation. He has an open question actually. What do you think about carbon capture and storage in deep water field development?
I'm actually working on CCS as well, but that's not deep water, and that is already challenging. I think there's several criteria, so you have to satisfy for the CCS. So you have to do the storage evaluation first. So if let's say it does not only confined to deep water. So as long as you have a proper storage, proper field that you can convert into a storage, then I think that's okay. But on the facility side too, is something that probably a bit more challenging lah. We are maturing on the surface for CCS, so let's wait for that to happen, and maybe we can see how we can move on to the deep water part.
Okay, Perfect. Wonderful. Thank you for that, Harni. The next question is from Mr. Anwar here. Have you seen nitrogen blanketing being effective in preserving the temperature for deep water? Is the nitrogen blanket usually intact over a long period of time?
I've not used it personally. So those are the area, the available. The one that I shared is actually the available options that you can analyze and use it for your well. And this actually is something that you really need to work closely with your cementing counterpart. So I've not, I don't think I will be able to answer that question for that nitrogen, because I personally have not used it. But to preserve the temperature, it will just give you flexibility for the fluid to expand. Yeah, I won't be able to answer that in much detail. Sorry.
No worries, no worries.
No
We
problem.
understand. I think you gave us a little bit of direction on who actually we should approach to get answers for that
Yeah,
type of.
find your cementing contractor.
Okay, okay, sure. Okay, the next question here is from Yusuf Ronald. Sorry, Yusuf Ronald. How long is the drilling duration for deep water wells roughly, and how much is the rig cost per day?
Typically that goes around 45 days to 60 days, including your completion. So it depends on what type of your completion. Like for example, in Malaysia, it's pretty much common for us to go with gravel pad. So gravel pad we take about more than a week. So we generally put around 10 to 14 days lah. So drilling wise depends on how long is your trajectory, how difficult or how many casing strings that you need. So it can range between 45 to 60.
Okay, that's the rule of thumb.
The rig cost.
Yeah, go ahead. The rig cost.
So the rig cost at the moment, based on our market trend, is around 220, I would say, around 220 per day. Sorry, $220,000 per day. The market is, is very volatile. So sometimes it shoots up, sometimes it goes down. So now we are around that range. Yeah. In those years, around 2012, 2014, the rig rate was 600K per day.
Okay,
yeah.
I believe that was the time where everybody was drilling and exploring and producing.
Yes.
Okay. Yosef had another question as well. What is the common data that you normally acquire during these types of drilling activities?
That can go, that can go, a lot, a lot. But we do appreciate. It's not that drillers don't like data acquisition. No, we do appreciate data acquisition, especially during appraisal campaign. So the typical one we would like to have is actually the core data. And the rest, the subsurface will generally ask for a lot of things like the seismic, the image log. So because in deep water, our formation is usually interbedded, so image log will help, especially to delineate some of your uncertainties. So, but don't take my word for you to, balloon up your data acquisition requirement. So you just need to balance out what is that you need and what is that you want, because the data acquisition will take some time, okay, and that will balloon up your well cost. So you have to find balance.
Got it. Perfect. Thanks for that, Harni. I have a few other questions, two more actually, two or three, two questions. The first one here is from Juhaidi. He's from MPM Upstream. His question is, what are the latest deep water well technology that's being implemented in Malaysia?
Technology. Let me think. Technology wise, I think one of the thing that is evolving is the rig. Rig. Now we are going towards seventh generation. So dual direct activity is already a norm. It's a norm actually, dual direct activity. So we should actually use this leverage on this new technology that the rig has to enable us to drill our wells and shorten our well duration. So dual direct activity is like you have a dual direct. So one derrick can do the drilling, one derrick can actually run your BOP until your seabed. So once you're done, you just switch. Because your deep water rig is very flexible, we can move, you can maneuver. RMR, the one that I said, he was used in one of the field in Malaysia, Malikai, if you know. Yeah, my colleague here, Saiful, also working towards automation. Yeah, a lot of things are moving into that direction, the technology. I've been out of operation for what 4-5 years now. So, but I do know certain things that are what we have in the market. Okay.
Thank you for that, Harni. There's a follow-up question from Irshad earlier who asked about RMR. How long is the interval normally left open in the annulus below the previous shoe, taking into account barite sagging? Any analysis to perform on this, or just a rule of thumb to determine how long is the interval left open between the annulus of the previous casing shoe?
Oh, the interval will be throughout your life cycle if you want to opt for that open shoe. So you have to run a detailed analysis and experiment to see, and also to work with your mud company to determine how much barite that will set throughout your life cycle. And one thing in deep water, you don't have the luxury of intervention. It's very expensive. So our philosophy is interventionless. So whatever that we plan, we have to plan it properly so that we minimize any intervention effort. Okay.
Okay, got it. Okay, I have 3 other questions. I'm going to take one last one. The remaining questions, my team is going to collect the questions and send it over to Harni. Harni will then respond to you because we're running out of time for the Kahoot session. So the last question I have here is from Jason. Could you help elaborate on slag cement or in situ hydrate mitigation for deep water drilling?
Sorry? Again?
He wants to understand a little bit further on slag cement on in situ hydrate mitigations.
Oh, okay. Slag cement is actually the type of cement that has less low heat of hydration. So you know when you produce, you have heat to dissipate. So through the cement itself will release some so when you have a low heat hydration, it will I don't know how to put it. Okay, it will release less heat during the hardening stage.
Okay, got it. So it actually it's not really a good conductor of heat, I would say, correct?
Yeah, as compared to the normal G cement.
Okay, got it. Okay. Team, can you just please help me collect the questions and the names of the attendees? Then we will get back to them after this presentation. So now let's move on to the Kahoot session. Just give me a minute. I'm going to start sharing my screen all again. It's slow. Just give me a minute. Just bear with me. It seems a little choppy, probably because the number of attendees as well. Okay.
System is quite heavy.
Yep. Okay.
First
I
time.
have shared my screen. Can you guys see? Or is it still loading? Harni, can you see my screen?
Yeah,
Now, yes.
actually, can.
Okay. Perfect. Perfect. Guys, what I need you to do is help me join through to the Kahoot quiz questions. What you need to do is actually you have to head down to www.kahoot.it and then you just need to type in your game pin. Okay, I see some gents coming in. Okay, good, perfect. Let's wait till probably another 3 to 4 minutes to get everyone on board, and then we'll start with the session. I'm just gonna turn off my camera to save some bandwidth. I think my internet is weak. Wow, Harni, you have a fan club. There's one person who joined in with the name Harni Fan Club.
You can get 50 ringgit
I
from this.
really like that. Ini macam, you know, Liverpool fan club ke apa. Ni fan club. Nice.
You guys are really, really creative with your names. Keep it going, keep it going. We're roughly about 150, and we have almost half on Kahoot. Come on, guys, 50 ringgit e-voucher. I think it'll last me approximately 2 days of lunch. So your lunch is going to be on SPE if you get all your questions right.
You can have 3 Starbucks consecutively, 3 evening to boost you up for the work. The remaining of the week.
You can work overnight for 3 days to drinking a Starbucks. Okay, we have half of them on Kahoot. So I'm going to give you another, let's say, 2 minutes to join in. We'll start at 1:21 p.m.
Let's hit 100. First time record as well. Come on, all, let's get 100.
I think
Together.
I think it's easily achievable. 20 more. Come on, guys. You guys can do this. Let's make the Kahoot session another record-breaking one as well.
Alamak, drop balik pula.
Probably connection.
Yeah, maybe connection. Mine also not very stable.
I guess that's all. Only 80 of them are interested in winning.
Okay lah, let's proceed. Still a record.
Okay. Okay then, guys. Keep your hands ready. Keep your phone ready. It's going to be a challenging one. That's almost 80. Okay, that's 90. Okay, it's increasing. 1 more minute. 1 more minute. Well, let's try to hit 100.
Abhinesh, do we have some music for Kahoot?
Yes, we do.
We do, but I think the connection.
Can you go to your the sound, the speaker, yep, adjust it to maximum.
Yep.
And maybe change the music type. We've been listening to the same type. Awesome. Thank you.
No sound, yeah.
Probably adventurous. Okay, we have 90. It's already 1:21. I think it's
wow. 91.
Okay. Hey guys, I think let's go ahead and start. If you want to take any more of your lunch time. Okay. Let's take the first question. 2 and 1. The first question that we have for today: what is the typical duration for Deepwater project from exploration phase to development phase? This is actually a bonus question because Harni mentioned with the note duration. You guys remember? And it's going to be a bonus question for you. Okay, 9 more people to answer. 2 more.
Okay, answer already.
Oh, we have more than 90 earlier. 90.
93 people answered.
Okay, half got it correct. Okay, we have 15 questions. So this is going to be the second one. Okay, try. Good try. Keep it going. Keep it going. Which development concept can be used for both dry and wet tree? I think this was Harni's second slide. Many images. Guys, come on, 10 more answers. Okay, again, another half got it correct. Let's see who's topping the charts. Oh, okay. Ice Cream is now leading. And Kahoot CEO is here also with us. Okay, good try, guys. Let's keep it going. The third question. Is the facility team a key stakeholder in collaborative well planning CWP for Deepwater? Yes or no question? Also Harni's first couple of slides. 6 more
Come on,
answers.
that's my fan club.
Wow. Almost.
Avinash, how come there's no sound?
I am not sure because I've already tried sharing my sound as well. Can any of you guys hear it?
How do we share?
All right, never mind.
It's okay.
No sound at all, is it? Give me a minute. Let's go on to the next question. I'll try rectifying it. Okay, Ice Cream is still leading it. Okay, fourth question is a true or false questions.
Can't see the window.
Cannot see the screen.
Sharing.
Okay.
Try to share screen with the sound, Avinash.
Give me. Okay, is it back online?
Yes.
Yeah, this question is on. Yeah.
Okay.
Sorry about that. Is the sound online as well?
Still no sound, Avinash.
Okay, give me a minute. Let me try to rectify this.
Okay, hold on, everyone.
Half
The
time.
next question is coming up soon. Let's rectify the sound. Lag.
Okay, Harlow is leading it. I don't know why the sound is not playing at all. Can you guys hear?
No.
Okay, I'm not sure. I can't cut the sound online.
Got ready now.
Okay, perfect.
Finally.
What is the maximum allowed Seabed well placement? I think Harni gave the answer out as well as a bonus earlier. Okay, we need 6 more answers. Okay, again, another half got it correct. It's 5 degrees. Okay, let's see the chart. Okay, Harlow is still leading. Ice Cream, we've fallen down to the 5th place. Looking for more from you. 6th question is shallow water flow manageable? Yes or no question? Very quick answers for this. 5 more answers. Time, 81 got it right. Perfect. Wow, SNFZ is on a streak. Harlow is still leading. 7th question, almost reaching the half mark. This is a multi-select question, so be fast. What are the components of in situ? Pick 2 answers. We have a quite good representative answer. Most of them got it right. Let's see who's leading. Oh, Harlow is still there. Okay, SNFZ is catching up quite fast. 8th question. Which of the analysts below can be bled off for subsea well? Okay, you can see, you can refer to the diagram for your answer.
diagram the answer.
Okay, almost half again. Got it right. Let's see who's leading. Okay, Arlo is still standing. Let's go to the ninth question of the day. Subsea well is easier to plan as opposed to fixed platform drilling. Yes, no, or it depends. Any more answers? Okay. Okay, again, we got the half.
Classical answer.
Yeah.
And
Okay, let's see who's leading. Wow, Snow's back up. Where did NFZ and Try go? Let's go on to the 10th question. What is recommended minimum well placement safe distance from mud volcano? 500 meters, 2 kilometers, 4 kilometers, 10 kilometers. Ten more answers. More seconds. Okay. Yeah. I think the half rule of thumb still applies for this question as well. Okay, let's see. How's the chart looking like? Okay, Snow is still leading. Okay, Harlow is back in the game. Let's see the remaining 4 questions. Which of the following can be categorized as seabed hazards? Multiple answers. Lilies,
hello, Assalamualaikum.
Hello. Assalamualaikum, Abang.
Okay.
I'm the lead.
Okay. Okay, then. Okay, we have a good spread of answers. Let's see the chart. Okay, Nick, our new leader, is leading the Kahoot quiz question. Okay, 3 more questions to go. In annular pressure buildup, the inner casing will experience, is it true or false? That's a pretty nice spread as well. Okay, SNFZ is catching up. Nick, good luck. 3 more questions to go. Oh, 2 actually. Annular pressure buildup can occur in injector well. Okay, most of them got it wrong this time. Okay, let's see the charts again. Okay, SNFZ is back in the lead. Okay, 2 more questions to go. FBSO is the most suitable. Okay, that's a pretty decent 80% got it correct. Let's see the charts. Okay, SNFZ, one last question, and if you get this right, you're our lucky winner. What is the preferred cement slurry to cement surface casing with input hydrate base? Because a lot of questions on this as well. Following the content, we will win. Anyone just do have a decent spread again. Okay, let's look at the podium. In place we have where and EPA. Winner of today is congratulations. Thank you guys for joining us here today. One last favor that I'd like to ask from all of you here is to please take some time to fill up our feedback form. It's going to be helpful for us to plan our upcoming events, not only the MIT talks, but any other talks that we're planning. Your feedback will be valuable for us. And we look forward to MIT Talk Series 2. Please follow us on our LinkedIn to keep yourself posted. And we hope to see you in more of our SPE events. So that's all I have from me here today. Thank you so much. It's been a wonderful experience for all the past 10 weeks with multiple talks. Hope you guys learned something as well throughout this journey with us. Anything else from the team, the program director or Chanwa, you have anything to share with our attendees here today before we call it?
Nothing from me. Thank you very much. Thank you, Avinash. And thank you, Ms. Harni. And all the speakers just like to highlight again that they do this all for free in their own free time, despite their busy schedule. So thank you so much.
Yeah, we appreciate all the speakers. Thank you so much, Harni, for joining us here today.
Thank you for all the speakers and as well as Harni. Thank you. Very good concluded session today. Very well received.
Yep. Like to thank Harni for helping us break our record. We had 200. Thanks for an interesting topic and the wonderful presentation. So with that, I'd like to conclude the session, except for those who won the Kahoot quiz. Please stay on. And we have also selected 4 lucky participants for the lucky draw. We will be sharing their names in the chat space, so please look out for that. And the others, I'd like to call it a day. Hope you have a good lunch ahead and a great week ahead. Thank you.
Look forward for further engagement with all of you. Stay tuned to SPE KL.
Thank you all.
All right, see you all.
Can we have the winner to stay on? SNFZ. And also, who won the can you share with us, Abinash, who won the 4 lucky draw?
Yep. Give me a minute.
Ipin kan?
So lepas ni Anwar tak
Yes.
ada lah no more series ke macam mana?
Actually, we will be having, for time being, we concluded the 10th one. So if there's a different program, then we'll come back lah. Maybe the next, macam apa orang kata, Netflix series juga kan? Ini season 1.
Yeah, the MIT series, this will be the 10th one, the last one.
10th one. Series
Yes,
10.
Season
1. Season 1, series 10. Season 2 belum buka lagi.
Episode 10 lah. So nak
Belum production lagi, Fahmi.
Tapi so far dia punya speakers punya there's no issue kan to get speakers.
So far okay lah. Quite kan?
We depend on the feedback form actually, because we gave feedback form, but we did not receive a lot of feedback from people. So it's actually good if we, because we gave option what kind of topic you like to hear. But so far tak ada banyak bagi feedback. So kalau ada feedback, and maybe we can do a survey online ke, then we know what kind of topic is hot, what kind of topic is not, right?
Kami, you asking that do we have able to find enough speakers?
Yeah, that's why I thought. Yeah,
oh,
it was
okay.
going to stop because
I think it's too overwhelming.
Much, yeah.
Quite a good support so far lah.
So who's SNFZ, this mystery winner? Is he still online?
Right, guys.
It's a SNF. Is it a polymer? I think it's a
Oh,
polymer.
it's
Yeah, it's actually the acronym of my name, Siti Najmi Farahah.
Oh, okay.
Oh, please identify yourself. Turn on camera, please. Boleh ambil gambar?
Give me 1 minute. Is that okay with you?
Sure.
Yeah, don't worry.
I'll be back in 1 minute.
Okay. Wow, it's quite a bad.
Season 1.
Wow.
Siapa cakap tadi? Is it Cik Mat ke? Anwar.
Itulah, he couldn't join lah. Apa nama? I think workshop SPE pun tak sampai 200 lebih. Yang ni memang exceeded lah. I'm like,
who was it just now? Anwar, was it Cik Mat?
I don't. He was in.
No, tadi yang cakap tadi.
Fahmi.
Fahmi from SKG, Senior Pitech. Itu dia Siti Najmi Farhan binti Zulkifli.
Jom
Assalamualaikum.
ambil gambar. Let's
Tahniah,
take one
tahniah.
picture with the winner.
Congratulations.
Bagus.
50 ringgit is coming in.
Boleh
Dah
ambil
ke?
gambar, Faiz?
Oh ya, saya. Okay, dah.
The mic. Siti, you're trying to speak, is it? Your mic, sorry.
Yeah.
Oh,
What about the lucky draw winners?
You are the lucky draw winner.
You are.
So,
No, I saw from
you are
Risha.
SPE
and
Hazard,
Ada.
right?
Ada.
Yeah, there are 4 of them.
There's
Can I-
4 of them, but I only see one. Chifami is online. I'm not sure if Irshad, Mark, and the others are online or not.
So,
I don't think
Siapa yang ada online lah. Fahmi, jom. Kat
Jom.
video. Kita ambil
Boleh?
gambar.
Okay, 1, 2, 3, smile. Okay, got it. Okay, one more time. Alright, the winner Najmi. 1, 2, 3. Alright.
Okay, back.
Okay.
Very nice
Miss-
pin tau. SPE punya pin. Very nice actually. Nanti wear with pride lah Cik.
So, Siti, I call you Siti?
boleh mana-mana. There are 3
Okay.
names you can choose.
I see. Congratulations. It's not easy to win out of like 80, 90 participants.
Players.
Exactly.
You prefer a Grab ke ataupun Touch and Go?
Probably Grab.
Grab. Okay.
Boleh order food lah. Grab food
They order some January.
Yalah.
Grab. Okay, I will send over to your phone, but you just have to make sure that your Grab can receive. Meaning dia ada macam like you have to
That's right.
apa tu? You have to authenticate something and then you can receive it.
Okay.
Okay. Alright. Okay. Thank you so much.
But you have my phone number. You have my
Oh
phone
yeah,
number.
belum ya. Yeah, phone number please.
Okay. 017
017
685
685
4953.
4952. Okay, so 017 685 4952. Grab eh?
53.
017 685 4953.
Yeah.
Grab. Okay.
Okay, thank you so
Correct.
much.
Okay.
Okay.
Thank you Avinash.
Kaidir. Assalamualaikum Kaidir. Oh, leaving. Terus dia leaving dah.
Leave first eh.
Okay.
Okay, everyone. Thank you. Job well done. Superb. Very, very good. Very, very, very good. Extremely satisfied.
Thank you so much, January.
Thank you, Avinash.
Okay. Take care.
Well done.
Guys. Take care.
Okay. Great job, Avinash.
Till the Netflix series season 2, we will just stay on
You
for a
guys
while.
back. You guys back.
Alright.
Give refresher.
Refresh.
Okay, sekejap before we leave, boleh tak somebody